Now that we've kind of taken a look at all of the individual parts of rational functions, now if we want to graph a rational function here, we can have a basic little strategy. Now keep in mind that the most of the graphing that you'll do for our class will be more of a sketch. It's not meant to be overly detailed, and a lot of times your testing of rational functions will just be from an identification standpoint, and so this will make it a lot more straightforward. So as we look at this example, we've kind of given you a strategy here. It says to graph the rational function, and so the first thing that we can do is identify very quickly the horizontal and vertical asymptotes. And so as our first part here, we'll want to determine what's our horizontal asymptote and then use factoring to identify vertical asymptotes, and or do we have holes in the graph somewhere, so we can determine whether we have point discontinuity or infinite discontinuity. So after we're able to do that, we can then actually go ahead and graph our horizontal and vertical asymptotes, and this is generally done with some dotted lines to kind of show us our barriers in this graph. Now, the next thing that's easy to do is to go ahead and find our zeros. So if we plug in zeros for our x values and our y values, we can actually come up with any x intercepts or y intercepts that would be useful. This is going to give us a handful of points on the graph, and as you can see here, that may not be enough detail to give us a good true graph. And so by taking the three parts of this graph, and so you can see that we have the first area, the second area, and the third area, then we can quickly t-chart a point from each area of this graph, and in doing so we can get a little bit more detail to the different parts of our graph, and then simply sketch the function the best that we can. So using these strategies, what I'd like you to do is to go ahead and work the three graphs from sample problem number 4, and do the best that you can in sketching those, and then come back and take a look at the solution. Okay, and as we look here at this first problem, what I've done is I've started by factoring the denominator. We can clearly see that we have non-removable discontinuity, which is going to create vertical asymptotes. The two vertical asymptotes are going to be x equals to 2 and x equals to negative 2. So I've just gone ahead and started by sketching this out. And you can see here I have x equals negative 2 and x equals positive 2 as my vertical asymptotes. Then what I did was I double checked my degree values, and I have a larger degree value in the denominator. This is going to tell me that my horizontal asymptote is the x-axis, y equals to 0. And so now I have my three regions of the graph to work with. Now what I didn't show you on the screen is I went ahead and t-charted a point or a handful of points from each of these three regions of the graph, just to give myself a reasonable sketch on each of these given parts, and you can see how that turned out. And if you wanted to verify that you sketched this appropriately, you could simply just punch this into your calculator just to verify. But this is good practice to work on these sketches, because you will not actually have a calculator on the graphing part of the test, and so this is very good practice. All right, and so now we'll go on to sample B. Okay, again we have a similar situation in part B that we had in part A. I've factored the denominator again to see that we have non-removable discontinuity. This gives us vertical asymptotes at x equals to 1 and x equals to negative 1. Second, I checked my degree values to check my horizontal asymptotes, y equals to 0. And now, as I told you before, I didn't t-chart this on the page, but I just did this very quickly. From each of the three regions of this graph, I've just t-charted a point to give myself a general idea of the sketch of the graph. Now, if you need to t-chart more points, that's perfectly fine. And again, you can check this on your calculator. So, all right. Lastly, let's try the last graph, sample C. And lastly, on this problem, I followed the same process. And you can see very similar results. So it's a good idea to get in the habit of practicing the sketching of these, or at least trying to identify the parts that you would use for sketching these graphs. This will give you good practice so that when you have to do any sort of graphing part without a calculator, you can quickly identify the given graphs according to their asymptotes, removable or non-removable discontinuities. Just their distinguishing parts will help you identify the graph a lot faster and not make you rely on the calculator.